30 marks. That is what at stake in the 2016 and 2015 UPSC CSE Mains question on transmission line. Today, we are solving the 26th problem on standing wave ratio and reflection coefficient along with 2015 numerical on distortionless transmission line. I'll show you the exact step-by-step calculation to ensure your answers are precise and exam ready. Let's dive into the first problem. This particular question of transmission line was asked in 2016. Let's read the 10 marker question. A transmission line has the following parameters. ZL is 200 minus J200 ohms. Z0 is 200 ohms. Determine the voltage standing wave ratio and the reflection coefficient of the line. What are the things given here? We have ZL, which is 200 J200 ohms. We have Z0 also given us, which is 200 ohms. And what we have to find? We have to find voltage standing wave ratio and reflection coefficient. Right. First, we will try to find out the value of reflection coefficient, as this is in form of ZL and Z0. Once we will get the information of reflection coefficient, we will substitute this in the relation between reflection coefficient and standing wave ratio in order to calculate the standing wave ratio. Right. Now, reflection coefficient. Reflection coefficient gamma is equal to, what is the formula? The formula is ZL minus Z0 upon ZL plus Z0. Right. We have the information of ZL and Z0. We will try to substitute and we'll extract the value of reflection coefficient. What is the value of ZL? 200 J200. What is the value of Z0? Minus 200 upon 200 minus J200 plus 200. Right. This is minus plus, this is gone, this will get added. Minus J200 upon 400 minus J200. We will take 200 common from numerator and denominator. 200 upon 200. What is left up? Minus J upon, this will be 2 minus J. This is gone. This is minus J upon 2 minus J. Now, what we will try to do here, we will make sure that this equation in the form of x plus iy, right? So that we can directly calculate x square plus y square tan inverse angle tan inverse y upon x. Right? This is our intention. So what we will do in order to do this, we will multiply minus j, 2 minus j, right? We will just multiply with the complement number, complement of this number, 2 plus j, right? And 2 plus j. We have not made any, right? This will be eventually minus 2 minus j2 into minus of j square, right? Upon, this will be 2 square minus j square, right? Now what I'll do, this will be, we are aware of this j square is equal to minus 1, right, from the complex number. So this will become j2 minus into 1, right? And this will be 4 minus 1. Now this will be minus will be minus j2, minus will be plus 1 upon 4 plus 1, which can be written as 1 by 5 minus j 2 by 5, right? There is nothing wrong. This we can also write as x square. This is x square plus 2 by 5 whole square under root of angle tan inverse. What is y here? Y is, from this we can see, right, y is 2 by 5 minus upon 1 by 5. Now this will be 1 by 5 whole square, 1 by 25 plus 4 by 25, right? Angle, this y will, this tan inverse, this is gone, this will be minus 2, right? Now this will be base is 25, 1 plus 4. As we know that tan inverse of tan inverse minus of theta can be written as minus tan inverse theta. So this will become minus tan inverse 2. This will be 1 by 5. That is nothing but 0.45 angle tan inverse of 2, that can be written as minus 63.43 degree. Right. This is the reflection coefficient we have calculated. Right. That is the first part of our answer. Now we know that what is the relation between standing wave ratio and reflection coefficient. What is the formula? VSWR can be written as 1 plus reflection coefficient. What will be the magnitude of this reflection coefficient? That is nothing but 0.45. Right. We will try to substitute this value in here. So this will be 1 plus 0.45 upon 1 minus 0.45. This will be 1.45 by 0.55, right? 2.62 is VSWR. This is the answer that we were looking for. Let's see another 20 marker question. This was asked in 2015. A distortionless transmission line has Z0 60, attenuation 20, phase velocity 0.6 c, where c is the velocity of the wave in vacuum. Find R, L, G, C and lambda at 100 megahertz. What are the things given in the question? We have the value of Z0, that is characteristic impedance, 60 ohms. We have attenuation, which is 20 milliampere per meter. We have the value of phase velocity, that is 0.06 c. And we have, what are the things we need to calculate? We need the value of R, L, G, C and lambda. These value we need to calculate for F is equal to 100 megahertz. Question was talking about a distortionless transmission line. See, for distortionless transmission line, right? We know the condition. R by L is equal to G by C, right? Then we can also write RC is equal to LG, right? This is the first we are aware of. We also know alpha is equal to RG, right? Attenuation constant is independent of frequency. for distortionless transmission line. And we also know that beta is equal to omega under root LC. It is a linear function of frequency. These three things we know, right? Now, what we will do now, we know that phase velocity, which is Vp, is equal to omega by beta, right? We have a omega, we know the value of beta, which is under root LC. Vp can be written as under root LC. We know the value of Vp, right? We will try to substitute. What is, okay, first this can also be written as Vp square 1 upon LC, right? Now this will imply, what is the value of Vp? 0.6. What is the value of C, right? What is the value? This is 0.6 C, right? So we will try to substitute this value here. 0.6 C. What is the value of C? 3 into 10 to the power 8 whole square is equal to LC. We will try to solve this value. Then LC can be written as we have calculated LC. We will call this as value 4. We also know that Rg is equal to alpha, right? From second we can say that, right? From second we can say that this will be from second, right? Rg can be written as, what is the value of alpha, which is 20 into 10 to the power minus 3 the whole square. Rg will become 400 into 10 to the power 6, right? Now, right, we know that what is, we know that Z0 is equal to L by C, right? Like how this comes, we can write directly also, or I can give you how this is coming. As we know that the formula of characteristic impedance is R plus j omega C upon L plus R plus j omega L and G plus j omega C, right? What we'll do, we can take L common. This will be L, this will be R plus R by L j omega upon, we can take common C from here. This will be G by C plus j omega, right? Now we know that from here, from the distortionless, right, transmission line, L by R is equal to G by C, right? So if we will substitute this value, so here what I'm saying, L by R is equal to G by C. So L by R and G by C, so hence become this, and this value becomes same, right? Then we can omit this, hence Z0 can be written as Z for distortionless transmission line. This can be written, that I have written it here, right? Now In the question, we have the value of z. Z square can be also written as L by C. Right? What is the value of z? That is L by C can be written as 60 whole square. This will be 3600. This I can call it fifth. What I'm trying to do here is from equation fifth and fourth. If you will simply multiply both, then LC into 1 L by C, that is nothing but 0.086 into 10 to the power minus 11. And what is the value of LC? That is 3600. C gone, L square is equal to this is the first value we have got. Right? We have L. Now similarly we can calculate C. So from an equation, let's suppose from equation this only, from equation fourth, right? L can be by L. What is the value of L? This is 3.3. Hence C can be written as 9.26 into 10 to the power minus 11. This is the second value we have got. Now from the equation of distortionless transmission line, R by G is also can be written L by C. If we have calculated the value of L and C, right, then R by G can be written as, what is the value of L? We have calculated 3 into what is the value of L we have calculated? That is this one, and we have value of C, and we will R by G can be written as, after calculation, 35997. Right? We can call this equation as sixth. From sixth multiplied by equation from multiplied with RG, right? So multiplied with RG, this will be RG into R by G is 3599.7 into 36 into 400, right? Into 10 to the power minus 6. G gone. R square is equal to now we have value of R. We can substitute in any of this form, and we can get the G value as 0.000333 per meter. We have calculated this also. Now we have to get the very last part of the equation, that is lambda. Lambda is equal to Vp by F, right? What is the value of Vp? 0.6 C, right? What is the value of C? That is 0.3 into 10 to the power 8 by 10. What is the frequency? At what frequency? Frequency is get 100 megahertz, right? And we have value of Vp that we have calculated. and we know the value of C, that 10 into 100 into 10 to the power 6. Right, this is gone. Lambda can be written as 1.8 meter. This is the answer that we were looking for. So we have calculated lambda, we have calculated similarly R, G, L and C. For this particular question, we need to know the distortionless transmission line and its condition.
Hey, great. Thank you so much for watching. Please subscribe to the channel Sinc UPSC for such videos. There are plenty of videos coming up for other subjects too. Happy learning.